We'll proceed in innovative approach in calculus, and we will see further we will see further to the product rule in derivative. We have done every permutation combination that is possible in product rule in calculus. Everything we have done, nothing, no stone we left unturned. So everything possible that we have applied in product rule of calculus. Now question is arising that where this product rule is used. Is it only for the computation or it is used at other places also? Product rule is heavy used while calculating the integral calculus. Now someone would say, I am 100% sure that there is no product rule in integral calculus. As far as integral calculus is concerned, there is no product rule. Okay, there is something called integration by part in calculus, in integral calculus. And integration by part in integral calculus is from the product rule in the differentiation one. How do you prove it? Okay, we will prove it that integration by part in integral calculus, indeed it is continuation of the product rule in derivative calculus. What is product rule? A into B, derivative of A into B is A into derivative of B plus B into derivative of A, or derivative of U and V. Derivative of U into V is U into derivative of V plus V into derivative of U. People who are accustomed of X and Y, they can consider U is a function over X and V is a function over X. U into V, differentiation of U into V is U into differentiation of V plus V into differentiation of U. Okay, so U into differentiation of V plus V into differentiation of U. That is differentiation of U into V. How we go along, very few people would be knowing that integration by part in integral calculus, indeed it is derived from product rule in differentiation. So how you prove it, that is a question. Okay, if that is the scenario, let's consider with the x function one. Consider that there is a function called f over x. So u equal to fx. I thought doing in uv only, this would be even simpler. So consider there is a function f over x is fx, and there is a function g over x is gx. So fx into gx. Now if I calculate the multiplication derivative of multiplication, that is fx into gx, then it is fx derivative of gx plus gx derivative of fx. Okay, if that is then what are you trying to prove then? Okay, I am trying to prove something. I am saying derivative of fx into gx, derivative of fx into gx equal to fx derivative of gx plus gx into derivative of fx. Now, now if I keep fx derivative of gx in one side and rest other side, then fx derivative of fx derivative of gx equal to derivative of fx into gx minus minus gx derivative of fx. I believe it's all right. So fx derivative of gx, fx derivative of gx equal to derivative of fx into gx minus gx derivative of fx. Okay, if that is true, what are you trying to prove now? Fx into derivative of gx. Consider derivative of gx, derivative fx, fx into derivative of gx. Now we are Now let's calculate integration of everything. I believe it's all right. So integration of fx into derivative of gx equal to integration of differentiation of fx into gx minus integration of gx derivative of fx. All right. If that is the case, then first of all, integration and then differentiation of fx into gx will turn into fx into gx. So now we have integration of fx into differentiation of gx equal to fx into gx minus integration of gx into derivative of fx or integration of derivative of limit. Okay, so integration of fx derivative of gx. Consider derivative of gx is another algebraic equation that is hx possible, right? If I have gx as a function, if I have gx as a function, then derivative of gx, there is a high chance it will lead into another algebraic equation, another algebraic function, hx. How do you prove it? There is a function called sin x. If you differentiate it, it becomes cos x, another algebraic function. One algebraic function is sin x. Differentiation of sin x becomes cos x. I have a function called x. Differentiation of x becomes 1. Algebra to numeric. No, I'm not talking about that. I'm talking about if it is fx is algebra, differentiating it becomes another algebra, hx. So now I have integration of fx into differentiation of gx equal to fx into gx minus integration of gx into derivative of fx. Let's consider the differentiation of gx is hx. If that is the case, then integration of fx into hx. Did we get what we wanted? Product rule, product rule in integration or different integration by part. Different integration of fx into hx, where hx is equal to differentiation of gx. So integration of fx into hx, where hx is equal to differentiation of gx. If that is true, then equal to fx into gx, fx into gx. If hx equal to derivative of gx, then gx equal to integral of hx. Opposite. If that is the case, then fx into dx become fx into integral of hx minus integral of fx into integral of gx into derivative of fx. Gx silently I can replace as integration of hx. If that is the case, then integration of fx into hx, integration of fx into hx equal to fx into gx will be replaced by integration of hx, fx into integration of hx minus integration of hx differentiation of fx. Okay, I'll rephrase it again. So integration of fx into hx, integration of fx into hx equal to fx integration of hx minus integration of differentiation of fx. I'm keeping fx this side because fx is everywhere at the first side. Integration of differentiation of fx into integration of hx. This is product rule in integral calculus. So we brought it. So actual was gx. Now we replaced by hx. Who cares? Who want to know that hx is actually derivative of gx, and that was actually the product rule in differentiation. At the end, if you convert differentiation into integration, then certainly one function will get integral form opposite. That is but natural as per the nature of integration and differentiation. What we achieved? We achieved something really. Integration of fx into gx equal to fx integration of fx into hx equal to fx integration of hx minus integration of differentiation of fx into integration of hx. What are you going to get with this? We'll try. Okay, what is the integration of x square? X to the power 3 by 3. Okay, I know it. The integration of x square is x to the power 3 by 3. Can you prove it? No, I don't know. What is integration of x square by 2? Can you prove it? Yes, I can prove it. The integration of x is x square by 2. If this is x-axis, then function over x is fx. If that is x, then it forms a triangle. Okay, this is origin. If this is origin, then this is x-axis. If this is x-axis, this is positive side of x-axis. If this is origin, if that is the case, then there is a line that begins from the origin and it goes like this. What is the equation of your line? Okay, line is nothing but fx. Everywhere there is height. Height is growing. If I go along x-axis, height keeps on growing. What are you saying this? Yes, it proves that height is dependent upon x-axis. More you go in x-axis, height is growing. What is your height? That is function over x. How it is function over? Certainly it is a function over x. Because when x is changing, then height is changing. This looks like height is tied with x. This and then it is a function over x. So height is function over x because x is changing, height is changing. Height is a function over x. Python function where parameter is x. If you pass x value, internally it does some computation and return a height. Pass another x value, it does some computation and return a value. What is your inside computation? What are you doing inside that? Can you tell me? Okay, nothing but whatever x you are sending in, same x I am returning. That is the internal logic of the function fx. So if x is 0, height is 0. X is 1, height is 1. X is 2, height is 2. X is 3, height is 3. What is your function fx? X. If that is the case, then what is the integration of fx? That is x. That is fx dx. X dx. I am trying to get integration of x along the x-axis. If it is along any curve or line, then it is called it is called line integral. That is another thing called line integral. That is used to calculate curl fundament. If it is integration along a particular any surface, then it is called surface integral. That is comes in flux calculation. Anyway, now I have x fx dx, x dx, integration of x. What is integration? Integration is nothing but calculating the underneath area. That is the integration. If this is x-axis and this is the function over x, whatever the area it is making, triangular area, that area computation is nothing but the integration. What is the area of a triangle? Okay, what at the end you are trying to calculate? We are trying to calculate the net addition. At the end, integration calculate the net addition. Net addition means at this point height is this, 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 at this point height is this. If like this, then what is the net height? If I am taking 10 samples, x equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples, and at each sample, this is the equation of the height. What is the net height? What is the net height? If I add all the height, how much it is? 0 plus 1 plus 2 plus 3 like this, how much it is? Then equation of the height is x. In that case, if you calculate the area underneath, that is the net height. At the end, we are trying to calculate the net addition through the area. If that is the case, what is the area? If this is triangle, then what is the area? This is the height of the triangle. This is other end of the triangle. If I make a rectangle like this with this height, the triangle area is half of it. If that is the case, then it is x squared by 2. If height is x at any point x, height is x, the rectangle area is x square. Then this triangle area is x square by 2. What is integration of x dx? What is integration of x? Then it is x square by 2. I know this very well. What is integration of x to the power 0? Then it is x to the power 1, x square by 2, x to the power 2, then it should be. If it is x to the power 0, then it is x to the power 1 by 1. If it is x, that is x to the power 1, then it is x to the power 1 plus 1 by 1 plus 1, 2. If it is x to the power 2, then integration should be x to the power 2 plus 1 by 2 plus 1, x to the power 3 by 3. Can you prove it? I don't know. I can prove it now with the product rule. Now, integration of x square we want, right? Then that is x into x we want. Fx is x and hx is x. Then equal to fx integration of hx. X into x square by 2. X into x square by 2. X to the power 3 by 2. Minus, and then integration, differentiation of first term, that is 1. Differentiation of x is 1, and integration of x is x square by 2. Now integration of x square by 2 we want. Left side is integration of x square equal to x to the power 3 by 2 minus integration of x square by 2. If I take this side, then we are trying to calculate integration of 3 by 2. Integration of 3 by 2 x square, integration of x square into 3 by 2. So 3 by 2 integration of x square equal to x to the power 3 by 2. 2 gone, 3 came this side. Integration of x square is x to the power 3 by 3. What is integration of x to the power 3? Integration of x to the power 3 is x square into x. Integration of x square into x. That is x square into x square by 2. X to the power 4 by 2 minus differentiation of x square is 2x. X square is 2x. 2x into x to the power 2 by 2. 2 gone, integration of x to the power 3 minus integration of x to the power 3. I believe it's all right. Minus first differentiation of, we are trying, I'm sorry, okay, first differentiation of x square, that is 2x. Integration of x is x square by 2. 2 gone, minus integration of x to the power 3. Same thing, right? We are trying integration of x to the power 3. This will go this side. Now it is 2 integration of x to the power 3. Now equal to x to the power 4 by 4. 2. 2 will come here. Integration of x to the power 3 is x to the power 4 by 4. Amazing, right? This way, people proceeded in integration of x. Now I am sure that integration of x to the power n is x to the power n plus 1 by n plus 1. If that is the case, then differentiation would be opposite. Then differentiation of x to the power n is n into x to the power n minus 1. Amazing, mind blowing, isn't it? Okay, that is the power of product rule. What is integration of x sine x? X sine x. Then x I can keep outside. Integration of sine x. Then it is minus cos x. Minus x cos x. Minus, now integration of differentiation of x, that is 1. Integration of sine x is minus cos x. Minus minus plus integration of cos x. Integration of cos x is sine x. Done, right? So minus x cos x plus sine x. I believe this would be. I never tried. So integration of x sine x is minus x cos x plus minus x cos x plus sin x. If not sure, I'll try differentiating it. Minus x cos x, if I differentiate it with the product rule, then minus x minus sin x, x sin x, plus 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 cos x and differentiation of minus x minus 1 minus minus sin x, and then I believe that side it was something like that. I believe it will cut. Okay, I'll try it again. So minus x cos x, this is what we are saying. Minus x cos x plus sin x is the integration of x sin x. So let's do the differentiation. Minus x, okay, minus x cos x. If I differentiate it, it becomes minus x minus sin x, x sin x, plus then I keep minus cos x outside and differentiation of x gone. So minus cos x, x sin x minus cos x. Okay. Now differentiation of sin x cos x, cos x gone, and it came back to x sin x. So nice, right? But why I'm bringing this point, mind it, when you take which term you take first and which term you take second. Integration of x sin x is same as integration of sin x into x. Let's see, let's take sin x before x. Then sin x will remain an integration of x, integration of sin x into x. Then sin x integration of x, that is x square by 2, minus differentiation of sin x is cos x into x square by 2 integration. Now it become bigger, can you see? Now if someone try integration of cos x x square by 2 and minus, if you leave it, then cos x x to the power 3 by 3 minus cos becomes sin, and then x to power, it keeps on growing. Okay, that is the problem with the product rule in integration. Integration, after all, integration is addition, multiplication. If you cannot control it, it will become bigger and bigger. That is the problem for the. So be kind of little bit attentive. What is the integration of sin x into cos x? Sin x into cos x. Then sin x integration of cos x, that is sin x, sin square x, minus differentiation of sin x, that is cos x, and integration of cos x is sin x, minus again sin x into cos x. Now if I can take this side, sin x into cos x integration, I can take this side, that is 2 integration of sin x into cos x. 2 will come here, this side, and it becomes sin square x by 2. Nice, right? What about integration of sin x into sin x? Sin square x. What is integration of sin square x? Then sin x minus cos x. First one, minus sin x into cos x, minus, and then differentiation of sin x, that is cos x, and integration of sin x, that is minus cos x. Minus minus plus integration of cos square x. You must resolve here only. Now it is growing now. Plus integration of cos square x. So integration of sin square x is minus sin x cos x plus integration of cos square x. That is cos x sin x. Cos x sin x, here minus cos, that is gone, 0. And minus, now integration, differentiation of cos x, that is minus sin x, integration of cos x sin x, minus minus plus, integration of sin square x is integration of sin square x only, no result. Okay, so differentiation, calculating the differentiation is something that looks like it is very much plausible. Causal means it is predictive. If you calculate product rule in differentiation, certainly you are going to get result. But if you are not clever enough and you are in a way to calculate the integration by product rule or integration by part, there are chances that someone would land up in this kind of non-ending situation where it will keep going like a chain kind of situation. Someone has to be very careful, attentive while calculating it. Okay, now this is the one thing that we have tackled, that is chain rule, product rule in differentiation, product rule in integration. What are the other thing in differentiation? That is differentiation, chain rule in differentiation. There are two things in calculus. One is product rule and another is chain rule. Chain rule means if you want to, like, what is the derivative of a square? What is derivative of a square? 1 by square root of a square minus x square. What is derivative of 1 by square root of a square minus x square by dx? I am trying to find derivative of a square minus x square to the power minus 1 by 2. 1 by a square root of a square minus x square is nothing but a square minus x square to the power minus 1 by 2. What is derivative of it with respect to x? Chain rule. First try to calculate the derivative with respect to a square minus x square. What is 100 by 100 by 100 by 10? 100 by 10. Okay, 100 by 10 is nothing but 100 by 50 into 50 by 10. Chain rule. 100 by 50, 2 quickly, and into 50 by 10, 5 quickly, 10. Otherwise, 100 by 1 is very big, 1 is very small, intermediate. Okay, you get the shock, but mild in a chain rule. Chain. This is what the fundamental of pulley, right? Okay, means how you distribute the power from slowly. Okay, whatever. So, kind of that is like this. So, chain rule in differentiation. So, all of a sudden, if someone is asking, can you find differentiation of a square minus x square to the power minus 1 by 2 by dx, anyone would faint immediately. How I can do this much? Okay, no problem. Do the differentiation with a square minus x square first, and then differentiation of a square minus x square with respect to x. This much you can do, right? Yes, I can do. Now differentiation of a square minus x square to the power minus 1 by 2 by difference by d of a square minus x square, it is as good as dx to the power minus 1 by 2 by dx. If that is the case, then it is minus 1 by 2 into x to the power minus 3 by 2, minus 3 by 2. So minus 1 by 2 and in bracket a square minus x square to the power 3 by 2, or minus 1 by 2 into 1 by a square minus x square to the power 3 by 2. Now into differentiation of a square minus x square by dx, that will come as minus 2x. 2 gone, minus gone. Now it is x by square root of a square minus, x by a square minus x square to the power 3 by 2. This is chain rule in differentiation. Now what is synonyms? What is exact counterpart of it in integration? That is also called method of substitution, where you substitute something so that life will be easy and then later you can get it back. What is integration of 1 by square root of a square minus x square dx? In integration, there are three parts. One is limit, one is integrand, and one is differential. So differential is dx and integrand is 1 by square root of a square minus x square. Same. Okay, if that is the case, then let's do same thing. First, rather than tackling directly with the fire, that is dx, let's convert x equal to a cos theta. X equal to a cos theta. Earlier, it was in differentiation d of square root d of a square minus x square to the power minus 1 by 2 by x. Let's tackle it first. Let's consider the bottom x as a square minus x square, and then like that, similar. So let's consider x equal to a cos theta. If that is the case, then 1 by a square root of a square minus x square becomes 1 by A I can keep outside the square root of 1 minus cos square theta, sine theta. 1 by A sine theta. If that is the case, then what will dx a 1 by a sine theta dx x equal to a cos theta, then dx equal to a minus sine theta d theta. Now that can be minus a sine theta d theta. A gone, sine theta gone, minus d theta. Minus I can keep outside. Integration of d theta is theta. Integration of d theta is theta. I can bring back theta. X equal to a cos theta, then theta equal to cos inverse x by a. That is the integration. Cos inverse x by a. Can tell me who is in this world that much powerful that if he knows that x square x to the power n integration is x to the power n plus 1 by n plus 1, and directly he integrate 1 by a square root of a square minus x square dx, and he will come to conclusion that it is cos inverse a by x. Not possible. No one can do like this. Cos inverse x by a. Anyone can do? Not possible. But method of substitution or chain rule brought this much. If integration is happening from minus x equal to minus a to a, like typically in the case of circle, minus a to a, now it is cos inverse minus cos inverse x by a, where x is minus a, cos inverse minus 1. Cos inverse minus 1 is pi, and then to a cos inverse 1. Cos inverse 1 is, I believe, 0. Cos inverse 1 is 0. So it is pi. And okay, minus was outside, minus pi or something like that. So it is something that the idea is to do all the churning possible in the calculus between differential calculus and integral calculus, so that if person is able to face difficulty while differential calculus will have no difficulty. This is what I believe so. If person is facing integral calculus difficulty, how somehow he can quickly jump into differentiation part and solve the problem and try to reverse it. That is the idea of the product rule and chain rule. What else? Now we will see. Now, if you remember, if what we were doing is two branches in the calculus. One branch talk about integral calculus, that is nothing but polynomial calculus, also known as polynomial calculus. Differential calculus, it is also known as first principle. First principle means if I have x-axis and this is the curve at point x, what is fx? And at point x plus delta x, what is fx? Now, if I subtract this one fx to another fx, if I subtract the height, divide it by delta, that is dfx by dx at x equal to x. Okay, or if this is x, if this is x, and if I go delta x unit along x direction, then for x, if this is fx, then how much fx moves? Okay, if x moves delta x, then how much fx moves? That is dfx by dx, or fx plus delta x minus fx by delta x. What is differentiation of sin x? Sin x plus delta x minus sin x by delta x. If that is true, sin x plus delta x is sin x cos delta x plus sin delta x into cos x minus sin x by delta x. So sin x cos delta x. Since delta x tends, this is what I don't want. Since delta x tends to 0, so sin x cos delta x is sin x. That is 1 plus sin delta x into cos x by sin delta x into cos x, okay, by delta x. Okay, if that is true, then I would try it again. Okay, so we are trying sin x plus delta x minus sin x by delta x. Okay, that is differentiation of sin x. Fx plus delta x minus fx by delta x. What is sin x plus delta x? That is sin x cos delta x. Sin x cos delta x. plus plus sine delta x cos x minus sine x. Now sine x cos delta x, since delta x tends to 0, cos 0 is 1. Sine x and minus sine x, both are gone. Now we have sine delta x into cos x by delta x, that is cos x into sine delta x by delta x. Since delta x tends to 0, then sine delta x by delta x is 1. So differentiation of sine x is cos x. This is something that we don't like. What is the differentiation of sin x without delta x? This is what the question. Or can I minimize this delta x fundamental? Two places there is approximation. One is delta x tends to 0, then cos x become 1. One is delta x tends to 0, then sin delta x by delta x become 1. So can there be another way we can find differentiation of sin x? So that is the question mark that we will see. Please do support us. That is our invention. Please do support us. You may find it also, but we did better. Okay. Please do support us. Plus 91 is the India country code 9483160610. That is the telephone number. Plus 91 is the India country code 60. I'm sorry. Plus 91 is the India country code. Telephone number is 9483160610.